Hello everyone, we are going to solve problem 99 of chapter 2 in this video. The load A, the load at A creates a force of 60 pounds, so the unit is in pound, in wire AB. Express this force as a Cartesian vector acting on A and directed toward B as shown. So again, in this problem, we have only one force. We are not going to combine the forces together to find the resultant force. We just need to find the Cartesian form of our force. So our force, we have the magnitude. We just need to find the direction. Here we don't have the angles, but we have the dimension. So we can find the unit vector. So our approach is the same. We want to find force F. We have the magnitude is 60. We're going to multiply it by the unit vector. Unit vector from A to B. What is a unit vector? It's just a position vector divided by its magnitude. So our first task is to find the position vector. What is the definition of a position vector? The coordinate of B minus the coordinate of A. So sometimes it helps if we write the coordinates. If you look at it, point A is on Z-axis, which means that the coordinate of x and y for point A is 0, because it's the bottom of our z-axis, so it would be -10. And remember, the unit is in feet. B, here the question has not directly given us the coordinate of B. If you look at it, B is on this circular ring, and then we have the radius and the angle. So 5 cosine 30 will give us this position in y, and 5 sine 30 will give us the position in x. And in both cases, it's going to generate positive value because we are in positive x and positive y. So coordinate of B would be 5 sine 30. Sine 30 would be 0.5. And 5 cosine 30. And because we are on xy plane, so it doesn't have any z component. Z component would be 0. So we wanted to find RAB, so coordinate of B minus the coordinate of A. So that would be 2.5, 2.5 square root of 3, and then 0 minus -10 would be +10. So if I want to write RAB, that would be 2.5, 2.5 square root of 3, and 10. But I found position vector to find the unit vector. So everything here divided by its magnitude. So 2.5i plus 2.5 square root of 3j plus 10k divided by the magnitude, each component squared, so 2.5 squared plus 2.5 square root of 3. I'm going to put everything in parentheses so we know all of them are going to be squared. 10 squared, write 100. So at the end, the answer, I'm going to write it here, that's easier, would be 0.224i, 0.387j, and 0.89k. That's our unit vector. So we found our unit vector to find our vector in Cartesian form. So we just need to multiply force F, that 80, that 60, the magnitude by UAB, which that would be this value. Gives us 13.4i plus 23.2j plus 53.7k. That's the force. Here the force is not Newton, it's pound. We write the unit. So we represented our force in Cartesian form. All we did, we multiply the magnitude by the unit vector. Unit vector is the position vector divided by its magnitude. The coordinate of B was not directly given to us, but we had the radius and angle. So we could find the coordinate of B. And knowing the coordinate of A, the position vector was written and the unit vector.